Hi, I made a mistake. Last video or whenever this video comes out, I made a mistake in number 15 of the 24 calculus 2 reviewer. And I gotta say, I'm disappointed in myself. I will now proceed to do a correction of this question. So, the question is e to the 2x sine 3x dx. What is the integral of that? So, the point still stands. We still use the DI method here. And the principle is still the stop number 2, which is that there is repetition. Nothing changes about that. How is the repetition? Well, let me show you. Again, let us set up the DI method with the pluses and minuses here. And then the D, let's say e to the 2x, and then for the I is sine 3x. Alright. E to the 2x. What is the derivative? It's 2e to the 2x. What is the derivative of that? 4e to the 2x. Nice. Sine 3x. What is the integral of that? It's negative 1/3 cosine 3x. You can cross-check that if you want. What is the integral of this? It's negative 1/9 sine 3x. So now, we see a repetition. E to the 2x here, sine 3x here. That's good. So, we multiply this and this, and then we set this to be the integral. This too. Alright? So, let's rewrite this. Let's write this, the integral, as I. Alright? So, it's easier to write. I, or that's the integral, is equals to negative 1/3 e to the 2x cosine 3x. Then there's minus here and minus here, so it's plus 2/9 e to the 2x sine 3x. Again, the integral is the I. This is not I. This is just e to the 2x sine 3x. But now, next part, there is e to the 2x and sine 3x, and we need the integral of that. So it's minus 4/9, and then I. Again, this is minus 4/9 integral of e to the 2x sine 3x. That's why I just put I in here. Now, next step is to combine everything that has I in it. So here, go here. So we do that by adding 4/9i to both sides, or transposing whatever floats your boat. But this is where the mistake happens. I accidentally wrote 13/4 back then. It's actually 13/9. Alright? And then we just arrange this to make it prettier. So, I want 1/9 e to the 2x to be here. So, sorry. This becomes negative 3 cosine 3x. Now, if you multiply this and that, this is what you get. Alright, so now 1/9 is negative 3 is negative 1/3, so that's fine. E to the 2x cosine 3x, so that's correct. Plus, this is now 2, so 2 times 1/9 is 2/9. That's easy enough. And then sine 3x. Alright? So now to isolate I, which is what we want, we just multiply both sides by 9/13. So this and that cancel, this and that cancel, and this and that will cancel. So that's good. So now the integral is, there's 13 here, so it's now 1/13 e to the 2x. Then let's rearrange it a bit so that the positive comes first. So 2 sine 3x minus 3 cosine 3x. Then we add plus c as is custom, and there we go. That is the actual answer for this question. Yeah. But I'm not satisfied with this alone. Let's do it another way. A more complex way, if you will. That's right. 15b. Alright, this is the second part. Another method. For this method, I want to use Euler's identity. You may know that e to the I pi is equals to negative 1. You may have heard that somewhere else. But have you heard of e to the I theta being equal to cosine theta plus I sine theta? If you're learning math or whatever, this, you may know this as the rectangular form, and you may know this as the polar form. Alright? Actually, there is r here uh, for the magnitude of the point of the line that we're talking about, but e to the I theta equals r e to the I theta equals cosine theta plus I sine theta is good for now. That is what we want to use. And the proof of this lies in Taylor's series and whatnot, so you can search for that. But what we want is to isolate sine here and cosine here, because since we can connect to the something, e to the power of something, to cosine and sine, maybe we can isolate sine and cosine to, you know, to represent it in terms of the complex numbers. So, how about we try this? E to the negative I theta. Well, this is just e to the I and then negative theta, right? Negative theta takes place of this theta right here, so we can say this is cosine of negative theta plus I sine of negative theta. Cosine of negative theta is cosine theta. Since cosine theta is an even function, cosine is an even function, and sine is an odd function. Right? So an even function, if its input is negative, it still remains positive, or like this. And then an odd function will go negative on this one. You can see it on the graph. The graph of cosine would look like this. So it's symmetric around the y-axis. Therefore, a cosine is an even function. Whereas sine would look like this. So sine, and let's label this. So sine is an odd function because it is not symmetric. In fact, it's anti-symmetric. So if you make the input negative, the output would be also negative. Alright, now that we have these two systems of equations here, we're going to start isolating cosine and sine. First, let's isolate cosine. So let's add these together. This and that. This is equation 1, this is equation 2. So we're adding 1 and 2 here. So the e to the I theta plus, well, this is just basically e to the negative I theta. Cosine theta plus cosine theta, 2 cosine theta. I sine theta minus I sine theta is 0. So I successfully isolated cosine. So cosine theta is then equal to e to the I theta plus e to the negative I theta. Oops, that's too big. Over 2. That's the complex that is the complex form of cosine theta. How about sine theta? Well, how about 1 minus 2? This becomes e to the I theta minus e to the negative I theta, which is then equal to cosine minus cosine is 0. I sine theta minus negative I sine theta is 2I sine theta. Two negatives make a positive after all. So, let's divide both sides by 2I. So, sine theta then is equals to e to the I theta minus e to the negative I theta over 2I. And that's what we're going to be using today. So you might say this is tricky, but it's actually really cool. Watch this. So our original one is e to the 2x sine 3x. Let's replace sine 3x with this identity. Nice. So the original, let's write the original first. E to the 2x, then sine 3x dx. Let us then replace the sine part with this part. So this is becoming e to the I, then theta is 3x. This is theta. So times 3x minus e to the negative I times 3x over 2I dx. 2I is just a constant. It's imaginary, but it's just a constant, so we can put that to the side. And then e to the 2x multiplied by e to the, let's rearrange this, 3ix minus e to the negative 3ix dx. I can't fit it in there. So, what do we do with this? We'll distribute it. The first rule is the logarithm rule is if you're multiplying something with the same base, you can add their exponents together. So e to the 2x, e to the 3ix, you can add that together in order to get, let's put this here first, e to the 2x plus 3ix minus e to the 2x minus 3ix dx. Let's rearrange this together. Factorize the x out in the exponents in order to get this. 2 plus 3x here, and 2 minus 3i times x here. This is just complex numbers. There's nothing special about them. They're just also constants, alright? But they have complex, stuff about them. So now, what do we do here? Well, let's just integrate it like normal. So, this is 1 over 2i, and then, what's the integral of this? Well, we copy it, so that's the integral of e to the x after all. And then the reverse chain rule, since this is just a constant, we can multiply this by 2. 1 over 2 plus 3x. So if you find the derivative of this, you will find this. So it's correct. You can double check that, by the way. So, and similar for this one, let's just put this here. And voila. And that's the answer. Hold on. This looks a bit difficult to read. And it doesn't look like the answer earlier. It just looks weird. So let's try finding if there's connection to the sign, the earlier answer. Let's remind ourselves what the earlier answer is. It's actually this. 1 over 13 e to the 2x, 2 sine 3x minus 3 cosine 3x. If that's in here, then maybe there is a chance that these are the same thing, that I'm doing something correct. So let's set aside this 2i for now. Just put it way outside. So 1 over 2 plus 3i. I don't like to be on the bottom. I likes to be on the top. So in order to erase this I on the bottom, we have to multiply it by the conjugate. So 2 plus 3i here, and then we have to multiply both the numerator and the denominator by its conjugate, which is 2 minus 3i. Then copy this one. Easy enough. Minus, let's do the same here. Let's multiply it by the conjugate, which is 2 plus 3i. Alright. Then multiply by the thing with the e and the x. There we go. Okay. Alright. Chop chop, my guys. So 2 plus 3i, 2 minus 3i, 2 minus 3i, 2 plus 3i. The denominators are the same. So what is 2 plus 3i and 2 minus 3i multiplied together? So 2 plus 3i, and then 2 minus 3i. That is just the difference of two squares. So this is 4 minus 9i squared. By definition, I squared is negative 1. This is one of the earliest things we know about imaginary numbers. So this is actually 4 minus minus is plus 9. 13. Remember 13? That's the number we had earlier, right? So let's go back here. Look at that. There's 13 here. So this is a good place to start. There's 13 in the denominator. So that's good. 1 over 2i again here. So let's just put that on the side. And then 2 minus 3i over 13. Then e to the 2 plus 3i to the power x. Minus this. 2 plus 3i over 13 again, since this and that are the same. E to the 2 minus 3i times x. There. Next step. Let's separate everything with no. let's unpack this thing first. So 1 over 2i here again. So 2 minus 3i, actually I want this to be 2 over 13 minus 3i over 13, and then there we go, 2 e to the 2x e to the 3ix minus 2 over 13 plus 3i over 13, right, e to the 2x e to the negative 3ix. Alright, let's put everything, let's put e to the 2x onto the other side. So 1 over 2i here, then e to the 2x, and then this is going to be what's left. Alright, so let's put e to 2 over 13. So now this is gone, so this has been transported to the other side. Let's rewrite everything. So 2 over 13 minus 3 over 13 I e to the 3ix minus 2 over 13 minus 3 over 13 I e to the negative 3ix. Alright, here's the spice part. So let's distribute e to the 3ix, and then let's put everything with 2 over 13 on one side and everything with 3 over 13i to the other side. So, 2 over 13 e to the 3ix, then minus 2 over 13 e to the negative 3ix minus 3 over 13i e to the 3ix minus minus is plus, plus 3 over 13i e to the 3ix. Alright. Okay. So something's growing out, right? Especially the 13 over there. Let's put it outside. Alright? Let's put it outside. Alright? And then let's put 1 over 2i closer to where we want it. So now it's 2e to the 3ix minus 2e to the negative 3ix. Let's actually just clean this up for a moment before we proceed, because something is emerging. So 2 times e to the 3ix minus e to the negative 3ix. And then oh baby, this is gonna get good. All right, is everything correct? So let me just check. No, there's something wrong about it. Okay, so sorry, this is supposed to be plus and that is supposed to be a minus. All right, we're heading somewhere, guys. So this is now minus 3 and then I, so there's I here, and then e to the 3ix plus e to the negative 3ix. Can you hear? Okay, can you see it right now, guys? Let's distribute 2i to the to inside. So e to the 2x over 13, which is what we had earlier, which is extreme, it's right there, 2 times e to the 3ix minus 3 e to the negative 3ix over 2i minus 3 times I over I. Since there's I on the denominator and the numerator, they can cancel each other out. Oh. And then e to the 3ix plus e to the negative 3ix over 2. Okay, to be clear, yeah, never mind. What can we see here? So remember, cosine theta is e to the I theta plus e to the negative I theta over 2, and sine theta is e to the I theta minus e to the negative I theta over 2i. So this is sine 3x, this is cosine 3x. Alright? So let's rewrite everything in terms of the sine and cosine. So 2 sine 3x minus 3 cosine 3x plus c. Let's compare it to the original answer. E to the 2x over 13 times 2 sine 3x minus 3 cosine 3x. Here is e to the 2x over 13, 2 sine 3x minus 3 cosine 3x plus 3. So we're done. We've proven that this is the actual answer using two different methods. One normal DI method and the other using the complex numbers. Complex form, you know. So that's amazing. I can't say anything. I don't know. It's just so amazing, man. That's all for now. I'll see you later.